YouTube, back on the Vise rebuild. We've made our cuts in the bed, we've butchered our moving jaw, and now it's time to make a new piece for this baby. I went ahead and took a piece of steel and laid it up into the bandsaw and cut it to rough length, a little long here, and we're going to continue to trim it down closer to size. It's obviously way too big, and then we're going to talk about attaching that. Had a little new tool acquisition, so I wanted to go over that with you real quick. As you can see here, I had quite a acquisition of cutters, milling cutters off of eBay. These are mostly radius style. Got a 5/16, got a 1/4 inch, got a 3/8, got a 3/16, 5/8, 5/8, yet another 5/8. Feels about a half. Yeah, this is a 1/2 inch. Another 1/2 inch, probably. Yeah, 1/2 inch. Another 1/2 inch. Maybe 9/16. Half inch. A couple of slitting saws. Well, these are actually staggered tooth cutters. You could use them as slitting saws. They're 3/16 by 1 1/4 arbor, and then I'm guessing this is another 5/8. Yeah, another 5/8. A couple of other cutters. Here's a real beauty, something you don't get to see every day. This is a completely unused, new old stock Niagara 5 by 3/16 by 1 1/4. Fairly late, obviously, because it's tin coated, which in terms of horizontal milling cutters didn't happen until fairly late. I don't want to know what somebody paid for that thing new. I guarantee you what I paid was pennies on the dollar. Anyway, so we got a big new collection of cutters there to inventory. If you remember this, last week, our last video, I showed you the dividing head plate that I 3D printed. This is now headed to Brian Block this afternoon, maybe tomorrow, where he is going to put it on his optical comparator, and we're going to find out just how good a job the Lulz Bot 4 did placing the holes in this dividing head plate. Thanks to Brian for offering to do that. If you're not checking out Brian Block's channel, you're missing out. Link in the description. So go check it out. And we'll be linking to this video, and Brian does a video on this item here. It should be really a lot of fun. One more here. So anyway, I'm gonna get the gonna mark this up a little bit. We're gonna go to the vertical bandsaw and start cutting this down to size. And then once we get it close, we're gonna attach it. Once it's attached, then we're gonna mill it back down to finish size. I'm probably just going to clean this thing up all the way around, back, front, sides, just to be consistent. And so we'll go from there. carved off that big chunk on the bandsaw. Now we need to carve off another big chunk. So what we need to do is we need to mark off here. We need to mark off here, add 389 to that. That's a nice little mark. We're going to cut it thick so I can mill it down, but that works out to about 1 inch, 990. So I'm just going to measure 1 inch up, and we're going to go ahead and bandsaw off that little piece. So here's my part. Like I said, I like to do the largest side first. Make sure the part is deburred. If you used a bandsaw to cut it out, there could be some big burrs on there. And I'm not talking about taking a little Noga tool and deburr it. I'm talking about burrs, right? So what I'd like to do is take my biggest side up, like so. And I take a piece of soft copper wire. This is a annealed wire. It's a piece of copper wire that I annealed, softened up, and in this case it's a big piece of number 8. All right. Tap that back side down on the parallel a little bit. And we're in there. We're going to fire the machine up. We're going to cut our first side. All right, we're going to square this baby up. This is the block that's got to go in there. We got to get it nice and square. Got the block up here in the vise, and we're going to cut it. Trying to get my light out of the way here. This is a 8 flute, 2-inch high-speed steel mill. We're running about 80 surface feet a minute, and we're going to feed probably 3 to 4 to 5 inches a minute to get a chip load somewhere in the 3 to 5 thousandths range. We're going to be taking little skim cuts here, so let's get with it. Get the machine fired up. You can't hear anything after I do that. It's about 150 RPM. If you're used to working with smaller end mills, you know, sizes below 1 inch, 1/2 inch, 5/8, 3/4, other sizes that are real common for smaller machines. If you move up to a larger machine and you start finding yourself using end mills, 2, 2.5, 3 shell mills that are 4 inches in diameter, you really need to watch your RPM, because the old numbers you used to use will burn up a mill in a heartbeat with with these bigger mills. As you go up in diameter, the surface speed goes up proportionally, and you know, you're going to want to be careful with that. Alright, our first side is cut. I had to slow the feed down a little bit to get a decent finish. It's mild steel. Mild steel didn't finish great. Lots of times. Deburr, deburr, deburr. Alright, first side's done. Got a decent finish there. I had to slow down to do it, like I said. At 3.7 inches a minute, I was getting a terrible finish. But I slowed it down to 2.2 inches a minute, and that finish is pretty good. Now what we're going to do is we're going to put our reference side to the fixed jaw. This side here. And we're going to cut side number 2. Make sure that's clean. Using a piece of annealed copper wire right here to hold my part. Now the part that's hard to wait for. To wait for the back end of the cutter to come off the part. Does anybody agree with me that this little piece of the part right here takes 75% more time than the first piece? Just because you're waiting for it to come off the cutter? All right. That's side number 2. There's the finish. It's still pretty good. All right, side number 1 is marked right here. Side number 2 is now marked. Now, you might be tempted to roll over to side 3, but you'd be making a mistake. Keep side number 1 against the fixed jaw. Rotate the part 180 degrees. Down. I'm going to come up another 10 thou. Throw the chips the other direction this time. Be back with you in a sec. Alright, that side did not clean up with a 10 thou cut. So we're going to dial in another 10. Come back the other direction. Looks like we'll clean up on this pass. All right, that's side 3. What we just did was we did our side number 1, then we did our side number 2, then we switched to 180 degrees, we did side number 3. So 2 and 3 are now parallel, so we can use them and side 1 as a reference to do this top surface. Alright, so there we are. 1, 2, 3. Now we're going to put 2 and 3 in the vise. We're going to put 2 against the reference surface. We're going to put 1 against the parallel. We don't need the copper wire anymore. Touch off again. There we are, touched off. Lube up. Come up 10 thou. Well, 10,000 and clean up this side either. All right, there we go. 4-side square. I don't really care about the other two in this case. I will explain shortly. All right, our block is squared up on 4 sides. I don't really care about the ends because they're going to get cut off, right? When I cut this end and when I cut this end, right? To clean those up. So what I need to do right now is I need to take a bunch off of this height right here. It's still way too big. So everybody likes a little hogging. We're going to do a little hogging. Touch off. All right. I'm going to set the 0 here. $100, $200, $300, $400,000. Running a nice lift there. See if I can catch a couple chips. Making a nice chip. No vibration. There you go. A little hogging for the day. Here are some chips. It's a nice little chip. Not really any heat in it. I mean, there's no color in the chip at all, right? Probably could have fed a lot harder than that. But it left a nice finish. Let's get the part out. Pretty good. Can't complain. Nasty burr on the backside there I'm going to take off, but let's head back over to the bench and fit it up. Alrighty. That's not actually the total amount that needs to be cut off, but again, I can trim that off after we're attached and cut both. I can get this block attached. I can skim cut this side, skim cut this side at the same time, make sure they're the same height. Alright. Make sure I'm not going to slice a hand off. Alright.
Oh, wrong way.
So there you go. The last cut before we start to attach this is I want to cut this back here so that this area here extends over the casting and gives me some extra material to cut back to play with the fit. So one more cut. We need to get a measurement off of here. I need to, let me see, we can dike that up. Alrighty. Put this in here like so. All right, so we need to countercut all back here, and we still got the rougher set up in the mill, so we'll just go set this back up in the vise, and we'll cut this back basically this dimension here, which I think I left about 1/8 of an inch. This casting, this casting here, this edge of the casting is cast like this, so it's got draft on it in this direction. So this edge slopes quite a bit. My cut here was straight versus the center of the vise, which is what I wanted, but this has a lot of draft on it. So if it looks like it's a little off, it's because it is. There you go. Got my part back cut there. I'll relieve that 1/8 of an inch. Fits right on there where I want it. Got a lot to cut back here. Oop. Alright, YouTube, so you see where we are with the vise. A little fill in for some things I did on the vise that I didn't put on video for a reason that you'll find soon. Here is the threaded bushing that works with the screw on the vise. The fit is extremely sloppy. I mean, you can wiggle the handle around like that. So I was going to make another one. I looked at it, I kind of just, glanced at it, held my rule up to it, and thought, oh yeah, 5 pitch, square thread, 7/8 diameter. I got some stock. I'll just cut a new one. I'll just make a new bushing, and because the screw's in good shape. The screw's steel, the bushing's bronze. So I made a bushing, of which I will show you some video of the making of this bushing right now. So there you go. Nice bushing. Listen to this fit. It's nice, right? 932 bronze, very nice. Got ready to bore it. Got ready to thread it, do some internal threading, square threads, internal. It's gonna be some great video. Picked the screw up, did a little deeper investigation. Dang screw is square thread, 6mm pitch. I don't have any way to cut a 6mm pitch. So either I make a new screw and a new bushing, which I'm contemplating right now. I've actually got some Acme threaded rod over here, several different sizes, Nook rod, Nook Industries, great stuff. If you ever need Acme rod and you think that you can make it cheaper than you can buy it, you would be wrong. Link to Nook Industries below. Super well made, precision Acme rod and quality material for prices less than you can buy the material. Really, honestly. And it's rolled, it's not cut. So anyway, I've got some Nook rod over here, and I've got some 1-inch. It's either 5 or 6 pitch. I think it's 6 pitch. I've got some 1-inch 6 pitch Acme rod. So I could make a new screw and then just thread this, bore this and thread this for 1-inch 6 pitch Acme, which is a real good option. Or what else? Well, I mean, I could make a screw from scratch, but honestly, you know, 3 foot of this 1-inch 6 pitch Acme rod, I mean, precise, rolled, top quality stuff out of 4140 is like 30 bucks, right? I need a foot. Anyway, so that's where we are. That's a future project for the Vise. Still waiting on material for the little base plates that went on the bed here. Should hopefully come in today. Same with the material for the Vise jaws. I ordered some ground carbon steel, not tool steel, just some ground carbon steel, and for both of those. So hopefully that'll come in today, and we can continue with that. When we do that, we're gonna continue with the moving jaw here, and we'll just continue with this. I've got some ideas about the vise that might be a little unorthodox, but let me zoom the camera down and show you what I'm talking about. So here's the vise. You've been looking at it for a few videos. I'm really thinking about cutting the tab off of one side of the vise, maybe this side, and milling the whole side of this vise flat, including the moving jaw, so that the vise could be rolled to its side and used in a vertical manner. So that's an idea. I'd like your comments on that. I'm also thinking about doing the Tom Lipton adaptation the way he did his. He had a Kurt vise on his drill press, came with his clossing drill press. I'm gonna put a link to his video right up here, right above me, where he puts a plate under his vise and a torque arm off to a brace on the drill press table, so that you can slide the vise around all over the table, and the torque arm takes the torque and prevents you from having helicopter injuries, which is a really great thing. Anybody that's used a drill press has had a helicopter incident at least once. He's got a great story on his blog also, another link, about his first helicopter, maybe his only helicopter incident. So anyway, I'm thinking about doing that with the vise as well. I would like your feedback on that. So we may just get off the chain with this thing here in a second. Me and the vise may have a visit with the vertical bandsaw, and we may liberate it of several pounds of cast iron. And I'm like, why not? Let's try it. I look at this, I look at it as though this vise was free. Let's get medieval on this thing and just really change it up. So tell me what you think about those ideas. T-shirts are out, male and female. So T-shirts are out. I have men's tees and ladies tees on Tee Blaster. If you click on the Pocket Tee link, you'll see the ladies tee option. Link down below. So everybody has an inner Kilroy. Don't you feel it? I mean, you've all seen it. This is the most iconic piece of graffiti in the world, right? You want to let your inner Kilroy out. Check the link out below. Great Christmas presents. And St. Patrick's Day is coming. What is more cool than being a Kilroy on St. Patrick's Day? I can't think of it. Of course, I think being a Kilroy pretty much every day is cool, but that's just me. Be safe in the shop. I'll be back with you soon.